Hey guys, Mr. Riz here to help you out on this first section in Chapter 5. What we're going to be looking at in Chapter 5 are radicals and imaginary numbers. So kind of taking a step back from our typical like math and polynomials that we were dealing with, focusing on other types of numbers that we haven't been spending too much time on. So today we're going to get pretty radical here, and we're going to be simplifying radicals. So most of the time we've seen radicals, and you might have seen like radical 40 or square root of 40. So square root is a radical, and it's a special type of radical, but that's not the only type of radical that we have. So the square root of 40, you guys might have like used a calculator and typed it in and said, okay, that's about 6.32. And then there's a whole bunch of numbers on. Anytime we like just stop at the decimal and say 6.32, we are rounding. We're not giving the exact answer. But there's another way that we can express radicals, and that's by using the exact expression. And what we're going to do here is to use a method called prime factorization. All right, so here's how we do a prime factorization. What we're going to do is first we're going to break down the numbers to like what two numbers can we multiply to get that. And we're just going to keep going breaking down this chart until we can't get any more. So 40, we can say is 4 times 10. And 10 is 2 times 2. Or 4 is 2 times 2, and 10 is 2 times 5. So another way to think about 40, it is 2 times 2 times 2 times 5. That's one way that we can think about it. And we can't break either one of these down. We could say 1 times 2 is 2, but that really doesn't help us out. I also like to kind of cross out numbers after we break them down, so that way we don't need to see them. So if we want to get a number out of a square root, what we need to do is we need to have two of them to be the same thing. So what's going to happen here is an easy way to think of it is if we want one of these two to go outside of the square root, we have to get rid of the other one, because really we're saying 2 squared and then 2 times 5. So a 2 gets outside of the square root. And then this 2 and that 5, they don't have partners, so they stay inside. And so that we get 10. And just to kind of show you guys here, all right, square root of 40 is 6.324555. Okay, so just to show you, if I were to type in 2 times the square root of 10, and then click enter, we get the exact same decimal. So this is going to help us later on, once we get the hang of this, of how we can simplify some expressions, like if we're going to be multiplying or adding or subtracting or dividing multiple square roots together. All right, so let's keep doing this. The process is going to be the same. So this is just going to be one of those sections that we're going to practice until we really get the hang of it. All right, so square root of 50, break it down. All right, 50 is 5 times 10. All right, you can't break the 5 down. 10 is 2 times 5. So we're just going to look for partners. We have a pair of 5s. One gets to go outside if we get rid of the other one. And then we have a 2 that doesn't have a partner. So that means we have a 5 outside of the square root and a 2 left inside. We can always check our answers with calculators to see if the decimals match. But this is how we're going to show our answers now. All right, square root 32. All right, 32 is, let's see, well, we can be lazy. We can say that's 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. All righty. So here's an example. All right, we have a pair of 2s, and then we have another pair of 2s. So we can make this 2 go outside as long as we get rid of one of them. We can have this 2 go outside as long as we get rid of one of them, and that 2 does not have a partner. So when multiple things go outside together, they multiply, they team up. So 2 times 2 means that there is a 4 on the outside of the square root. And then this 2 did not have a partner. 2 left over. Keep this going. Okay, so now what we have is this next example, we have a cube root. So cube root is another radical, but we notice here that there's an index of 3. All right, if there isn't an index, we assume naturally it's an index of 2. All right. So when we break out a cube root, what we're going to do is we're still going to break down the number here. So 16 is 4 times 4, and then 4 is 2 times 2. And that 4 is also 2 times 2. But in order to break out of a cube root, think of it as like a tougher jail that you have to break out of. What you need is you need to have 3 of them for one of them to get out. So we have 3 2s here. One of them can break out if 2 of them go away. So it's like the higher level thinking here. And then that 2 doesn't have a partner. So the cube root of 16 is really 2 times the cube root of 2. Okay. Another aspect we can add to this is variables. All right. So if we think about with variables here, we're going to do this first one the long way and think of this more as like the square root of x squared. We can think as x, and y to the 4th is y. So if we break them down, we can see here we have 2 x's. We can have 1 go outside. We have 2 y's. 1 can go outside. We have another pair of y's, and another y can go outside. So that means we have an x that went outside, and then we had 2 y's go outside, and y times y is y squared. We have nothing left over inside the jail, inside the radical, so we don't need to put it. So here would be the answer. So another way that we could think of this here is all we did is we took those variables and we divided by the index. All right. So we took 2 divided by 2. Okay, that's to the first power. 4 divided by 2 is 2. All right, so if we go on to this concept here, what happens if it doesn't come out nice? So if you think about this here, if we take 5 and divide it by 2, that's 2.5. Or another way to think about it is we would have 2 pairs and 1 left over inside. Moving on to the y's, we would have 1 pair with 1 left over on the inside. And then the z's, if we divide 7 by 2, we'd have 3 pairs with 1 left over on the inside. The concept doesn't change if we have a cube root, it just changes the index number here. So, okay, if we take 5 divided by 3, that means we'd have 1 with 2 left over on the inside. If we take 8 divided by 3, gives us 2 with 2 left over on the inside. And then 7 divided by 3 is 2, but there would only be 1 left over on the inside. If you want to leave the 1s there, that's fine. Or if you want to just leave it as like x, y squared, z squared. Okay. So really here, I know this kind of seems super abstract, like when are we ever going to use this? This is just building our skill so we can know what to do when we actually get to like real problems that have, tougher math that we have to deal with. All right, if we have an index of 4, if we think about it, we almost have the exact same expression here. If we take 5 divided by 4, that means 1 gets to go outside, 1 gets to go left in. Okay, so we'd have 1 group of 4, 1 left over. I'm gonna move this screencastify away. All right, again, is this just gonna keep popping up? All right, now to the y's. Okay, we had 9. If we take 9 divided by 4, that gives us 2. There'd be 1 remaining. And let's see, 3 divided by 4 actually doesn't come out at 0. So that means that z cubed is just going to stay inside. It'd be nice to kind of push these closer together, but it's the same thing. All right, so let's merge this together now. Let's take, what if we have expressions that have numbers and variables? What do we do? So we're still going to break down the number like how we normally would. All right, so 44 is 4 times 11, 2 and 2. All right, since we're dealing with the square root, we only need to have pairs. So that means that 2 gets to go outside and 11 stays inside. All right. So 2 outside, 11 inside. And then we work on the variables. Okay, x cubed, if we divide that by 2, that gives us 1 on the outside, 1 left over inside. And then that y to the 5th, that means we'd have 2 pairs with 1 left over on the inside. All right, and so here's the answer. 2xy squared times radical 11xy. If you want to pause the video anytime if you think you got the hang of this, go ahead, do this. But I'm going to just keep going until we can see all the answers here. All right, cube root of 81. Okay, 81 is 9 times 9. 9 is 3 times 3. All right, so there's 81. Now with cube roots, we need to have 3 of them. So we got 1, 2, 3. Get rid of 2 of them, so 1 can break out, and we'd have 1 left over. So we got a 1, 3 outside and another 3 inside the cube root. All right, variable x to the 4th. All right, that means 1 could break out with 1 remaining. And then the y to the 5th, that means 1 breaks out, but we'd have 2 remaining. So you think about inside of the radical is like your remainings. Oh, look at that. They almost look very similar. All right, 4th root. Okay, 16. 4 times 4. 2, 2, 2, and 2. Okay. So 4th root, we need to have 4 of them. 1, 2, 3, 4. So 1 gets to go outside, or that 2 goes outside. We get rid of 3 of them. Okay, so nothing inside of the cube root. All right, now moving on to the x's. Okay, we get 5 divided by 4 gives us 1 with 1 left over. All right, 6. 6 divided by 4 is 1 with 2 left over. And we're just going to leave it like that, even though we might think about reducing the fraction now. Just leave it as 2 remaining. And then 8. 8 divided by 4 is 2, and there's no remaining. So there we go. All right, so 16. Okay, we're doing square root. So 16 is 4 times 4, 2, 2, 2, 2. All right, got a pair of 2s. 1 gets to go outside. Got another pair of 2s. Another one goes outside. So that means there's a 4 outside and nothing number-wise left over inside. All right, moving on to the x cubed. If we take the square root of that, that means 1x gets to go outside. The other x has to stay inside. And then y to the 7th. Okay, so 7 divided by 2 is 3 with 1 remaining. All right, cube root of 27. Here we go. 27 is 9 times 3. 3 and 3. All right, a cube root, we need to have 3 of them. So 1 goes outside if we get rid of 2 of them. Okay, nothing left over with the cube root. All right, x, 6 divided by 3 is 2 with nothing remaining. Is this going to come out nice? 10. 10 divided by 3 is 3, but there would be 1 remaining inside. All right, last problem here. 16. We're taking the cube root of 16x to the 4th y to the 6th. 16 is 4 times 4. 2 times 2, 2 times 2. Okay, cube root, we need 3 of them. All right, so that means we get to have 1, 2 go outside and 1 stay in. All right, notice how I like to kind of give some spacing just to keep the variables there. All right, x to the 4th, we take the cube root of that. It means 1 goes outside, 1 stays in. All right, right? Because if we divide 4 by 3, that's 1 with a remainder of 1. And then lastly here, y to the 6th, 6 divided by 3 is 2 with none left over. So there's our answer. So I know this seems kind of weird and abstract, but it's going to take some time before we start, adding, subtracting, looking at the graphs of them before we kind of can actually really start applying these to things. But, we're building our strength and our skills here to go through. So after this, you guys have a CYU to do to kind of just build your skills. And if you guys have any questions, make sure you reach out and ask. If not, thanks for watching. Have a good one.